There
Beautiful.
we go. Now we're recording because this is what people like. It's this early before the webcast banter
The 3 minute
where,
banter, webcast banter.
yeah, I have a lot of people that rate our webcast based on the beginning banter. I think
Oh,
that's
now you set the bar
That's
high.
so
that's
fun.
not fair, actually. So
I popped my collar for this webcast just in honor of your slides, John.
did you did? That's awesome. That's awesome. I don't
Can't
know.
lose those. That's why we show up early.
See. I got to show. Okay, so like Mark, let's see if I can get my webcam to fire up. Okay, so I've got the beard is coming back, Paul. Um, so I'm
Wait, did you
trying to not do the neck beard thing because you hate that. So, but
keep it clean?
I'm doing this. I'm doing this so I can show Mark how to turn on his webcam.
Oh boy,
So
Yes.
Mark, it's now your turn because you got a shirt. At least you said that you had a shirt.
this
That
is
was pretty
real. All
cool.
right,
So let's.
let's see
All
here.
right, so here we go.
All right.
I'm gonna
Oh, there
shut
you
off.
are here.
There he is. There he
There
is.
he is.
So he's
The
got his
end game
shirt. He's
on
gonna.
He's got to turn around. It's on the back.
here.
Wow,
And he even went for,
that's a large font. It's a large font.
can now he should. I was gonna.
Did you get that?
I was gonna try to get him. I was gonna try to get you to turn around and then do like duck lips while you
Oh,
do it. So
so
kind of like
I'm surprised
so
it didn't
kind of
just
like
come
like
naturally there as I was turning around. Could probably hold on. God, I'm
Good.
getting by my
I call it.
employees again.
I call it. There you go. I call it blue steel.
I think John and Mark John and Mark are in the same room. That's really weird, guys. I like how you organized that.
He's on the other side of the room.
Yeah, that's awesome.
How
If
does
you
he
hear
know what's on the back of his shirt? How does he know?
if you hear
All right, I'm
echo,
shutting off my cam.
okay, yeah, we
Yeah,
can turn.
that's a
I'm
pretty good plan.
shutting off my camera so I can conserve bandwidth. There we go. There we go.
Oh man, someone says they don't think that they couldn't see the webcam. Well, I hope everybody else saw the
Oh,
webcam because that was awesome.
I'm
Yeah.
just
Recorded,
gonna say
right?
that's not. I feel bad for people on this
Now, John,
moment.
I can tell your excitement level about this presentation is a little higher than normal because there's 4 exclamation points instead of the normal 2 or 3. So you must be like
Yeah.
you're on like level
Well,
4.
Paul, I knew that you were going to be on this webcast, and I know how much you hate exclamation points. So I have exclamation points just spread throughout this entire
Oh
webcast just
no!
for you.
Oh, did you exceed the
So
one lolcat limit too?
the one, oh no, hold on. I got one. Yep, I've got one lawcat and
One lolcat is acceptable. Yep, one lolcat.
me in a clown costume.
Clowns are that's okay. There's no clown rules. All right, so let's let's get started. I want to just thank everyone for joining us today for a fantastic webinar titled "Bro," as John put. This is the first in a multi-part series about doing threat hunting using open source tools, specifically Bro. I'm just here for like decoration today. I'm Paul Sidorian, the founder and CEO of Security Weekly and the CEO of Offensive Countermeasures. Again, thanks everyone for joining. John Strand, who is the founder of Black Codes Information Security and the CTO of Offensive Countermeasures, will be presenting on Bro today. Mark Dufresne from Endgame. And Mark, you have the coolest title, but I can never remember it. What is your title, Mark?
So threat research and adversary prevention. I'm the director of
Ad
that at Endgame. Pretty cool, huh?
Adversary
What?
Prevention. Yeah, I love that. Mark is here with us from Endgame, and Endgame is sponsoring this webcast, and we welcome our new sponsor, Endgame, to the Security Weekly Network. Super awesome research team, super smart people, great folks to work with at Endgame. So I guess I want to start, Mark, by just giving us a little bit of background about yourself and a little bit of information about Endgame.
Yeah, great, thanks. So, so Mark Dufresne, as we said, the director of TRAP, which means we build in lots of different ways to find malicious activity without signatures. So, Endgame has a endpoint security platform. It's a agent-based system. We have a kernel and user mode component on our agent. We are able to control tens of thousands of agents via our centralized management platform. Everything's API-driven, so you can kind of do whatever you want with our data. And we bake in detections at many layers of the detection problem. Again, everything trying to do things without signatures. So all the way from exploit prevention through detections of actions on objectives. monitoring resources and actions, kind of monitoring access to and actions inside the kernel in real time. Got some machine learning baked in, so hunting with an emphasis on generating high confidence detection. So all these things layered together to find bad as quickly as possible through our platform. And where we can, offer an ability to prevent and block these things in real time. So yeah, me personally spent about 13 years at NSA playing offense and then defense, and now in charge of a pretty solid research team doing a lot of different innovative things to find bad. So thanks for having me on.
Fantastic. You can find Mark's technical segment in our Security Weekly archive. So John, fabulous John Strand, who, like I said, is very excited about today's webcast, please take it away.
Multiple exclamation points.
Oh, yeah, and Mark will, I'm sorry, Mark
yeah.
will have, Mark, you'll have some slides at the end to show some people some more endgame related specific stuff, correct?
I think he's here.
I think, well, he might have gone on mute.
Might have. Well, I just said, yeah, I totally have slides, Paul. So
okay, great.
He's still
Thanks,
there,
Mark.
and I'll just pretend to be him. All right. Well, and also so people know, like Paul and I have have a number of criteria for vendors actually coming on with us. Number one, they have to not get pissed off about what we say during any Enterprise Security Weekly. Endgame was pretty cool about that. Number two, they actually have to know what the hell they're talking about. And if you want to see Mark talk about stuff, go check out the technical segment. It's awesome. And it's really cool whenever you have a vendor that actually can say things and actually explain what the hell they mean, which is a pretty big criteria. So please stick around. That's pretty neat. So this is a topic Paul and I have been talking about quite a bit. We've been kind of threatening to do this for a long time. And it really feeds in with what we've been doing at Offensive Countermeasures with our AI Hunt product that we've been working on doing hunt teaming. And if you take a look at hunt teaming on the network level, which is different than what Endgame's doing kind of the host level, if you look at it on the network level, there's a bunch of problems with this concept for many organizations today. And the main problem is people expect signatures. Like Mark was talking about a signatureless kind of engine. That's really hard for people to get their head around. If you look at it, HIPAA and PCI are just now coming around to the idea that you could have an AV engine without signatures, looking at something like Cylance, for example, or even using Bit9, and using that as an anti-malware suite is kind of a huge step, but these products have been around for a really, really, really long time. And when we start talking about Bro, people are like, well, is it an IDS system? And you're like, well, no, not really. Then what the hell do I want it for? Well, we're going to kind of cover why having kind of intelligence tools, not threat intelligence per se, but network level intelligence and host level intelligence in your network is so important, and there's so many great tools out there to kind of help get you started. So this is the first of this series. We'll talk about what Bro is, what it is not, why you want it, and some cool things that you can do, how you can get it up and running in like 5 minutes in your organization and start getting some value out of it right away. And before we got started, Paul was like, John's excited about this because of the number of exclamation points. I have lots of exclamation points anytime I present, but more whenever I present with Paul, because he goes through all of my slides for sales pitches and things like that and removes all of my exclamation points. So it's my little way of getting back at him. But the reason why we're really, really super excited about this is because it's going to take us a while to go through and kind of set up all the different things that you can do with Bro, configuring it, setting it up, and trying to get some intelligence out of it. So this is the first in that series. There are people like, is this Bro 4.0? Is this Bro 4.2? Just don't worry. We're going to be using the security onion. You don't have to get too deep into what specific version we're actually using at this time. So why would we use something like Bro? Why would you actually go through and actually start hunting in your organization? Well, if you're looking for an easy button, if you're looking for a tool that you can just plug into your network and it just magically runs and alerts come out and bad guys are locked off and you never have to worry about advanced adversaries and you have that silver bullet in computer security, I'm sorry, this isn't the tool for you. And it's actually funny, we have a lot of people that do get frustrated with that. They're like, well, if this isn't a tool that's going to solve our cybersecurity problems, we're not interested. And I swear to God, that's not a straw man for this presentation. Paul and I listen to people all the time talking about trying to find the silver bullet. We want automated response, we want automated detection, we want it to detect advanced adversaries that are bypassing traditional security products, and we want it all to work automatically. We don't have to worry about it, and that's not going to work. And that's kind of one of those reasons why we like Endgame, is Endgame incorporates a lot of those features, but really it's an excellent platform for you to actually go hunting for those adversaries and really cutting down that signal-to-noise ratio that plagues a lot of products today. So how do we get through that signal-to-noise ratio effectively in our organization? Well, like I said, you're not going to find the easy button whenever you're using Bro. You're going to have to get your hands dirty. And believe it or not, that's more than half the battle. Whenever you're trying to do cyber threat hunting in an organization, you're going to have to be willing to get your hands dirty. You have to. And in doing that, you're going to learn about your network. And that is a huge thing. For example, there's a lot of products out there where if you put it in a lab, like for example, you put 4 systems with product X, and you can drop dynamic link libraries, you can do all kinds of different malicious, awesome things on it. It's going to detect absolutely everything if you're watching those 4 systems. But actually scaling those up at a much larger environment, if we're talking like 10, 20, 30,000 systems, becomes this kind of this problem of dealing with white noise. And the only way you can start cutting through that is if you actually know what is signal, what's noise, and actually start cleaning things up. And the only way that works effectively is having a good bead on what your network looks like as well. So all of this basically boils down to traditional defenses are absolutely failing. And everybody right now in computer security is kind of playing the game that we've talked about in other webcasts, clean up on aisle 4. If there's a breach, you go and you clean up that breach, and then you go back into the back room or down into the basement for the IT crowd, and you wait for the next breach, and then you come out and you clean up that breach. You take the system offline, maybe you restore files from backup if you got something like ransomware put on the computer system, and you go back, and you're constantly doing security by waiting for really bad things to happen and then reacting to those bad things in your organization. So why is this happening? Well, a lot of our security products are passive in nature. If you look at IDS, you look at IPS, you look at antivirus, a lot of these products are basically an alert-based system that says something bad has happened and then you've got to deal with it. And SIMs are definitely in this category, and I'm going to rip on SIMs a lot more on the next slide here in just a couple of seconds. But the whole point of this is to try to get away from a passive level security incident response program and getting into threat hunting, where you're actively going out and you're finding the bad guys. And ultimately, that's everything that we've been doing, right? If you look at active defense harbinger distribution, we got tools like Honey Badger, Word Web Bugs to actually track where the bad guys really, truly are. You look at AI Hunt, you look at Rito, which release open source, and I'll talk more about that here a little bit later. These are products that actually get you interacting with the data to try to find beaconing behavior, try to find kind of anomalies in your organization. But it requires a security professional to be actively engaged on a day-to-day basis with what is on their network, what it is they're seeing on their host, what it is they're actually seeing on their network traffic, and being able to parse it. Paul had a quote, I don't know if we were recording when he said this, but he goes, you can just sift through bro logs all day long. And why? Well, if you look at bro logs, you see all kinds of different interesting things on your network, like user agent strings. You see weird IPv6 solicitations. You see systems trying to query out for WPAT, for web proxy auto detection. Maybe you'll see LLM&R broadcast packets. But as you start sifting through that data, just going through it, right? You start seeing all of these weird little things like odd user agent strings or ridiculously long URLs and weird port combinations. And Bro can give you that ability to kind of float through your data. But you got to have that type of mindset where you're going to start floating through your data. You're going to start creating filters. You're going to start doing some analysis on what is actually happening on your network. Bro is not a system that's going to be like Snort. It's not going to generate alerts. It's just not going to jump up and tell you something bad is ultimately going to happen. So what Bro is not. Bro is not an intrusion detection system. This is one of those big things. For years, there was a rift in kind of the IDS community between Bro users and Snort users. Snort users were like, Bro isn't an IDS system. And Bro users were like, yes, it's not an IDS system at all. And a lot of people in the Snort community basically were like, well, what's the value in it? If it's not actually going through and generating alerts and we can draw signatures from it, then what's the value in it? And for a long time, Bro was basically an academic level platform. A lot of universities were funding and supporting Bro. A lot of universities were actually implementing and using Bro in their organization, or they were just doing it for research projects and doing analysis. And it kind of sat really second fiddle to Snort for a long time. But now all of a sudden, over the past 5 years, we're starting to see this huge explosion in people using Bro. And it's not because Bro implemented some kind of super awesome killer feature. It's just really, if you look at security professionals that advance to a certain stage in their career where they start asking questions and they're looking for tools that can help them answer those questions, then all of a sudden tools like Bro become exceedingly powerful. It is not an alerting system. You know, you can try to write alerts around it. I guess you could try to do some level of signature analysis. And to be honest, there are actual conventions. We'll talk about some of those a little bit later, where they actually do some level of alerting and they do shunning and they do dynamic stuff with Bro. But really what they're doing is they're kind of tacking things onto the analysis engine that actually is pulling the packets apart and giving us the data associated with each of those packets and the protocols that are being used, and they can do other things around that. And that's really where Bro has a tremendous amount of power, is if you can actually break packets, you can do analysis for HTTP, for connection logs, for DNS, for X509 certificates, and so on, then you really have a good heart engine that you can then start building these other things around. And to be honest, that's what we're actually doing with Rita as well. Doesn't have a super awesome front end. We're going to be using a tool called Bro Cut a little bit later to actually start going through and cutting through the Bro logs to pull out the specific columns that are of interest to us. It is not a religious avocation, and no, it's not a frat member that's gone too far in the land of popped collars. So this is what Bro is not. This is what we're ultimately trying to avoid, is trying to pigeonhole Bro into an IDS system. And yesterday, before we did this webcast, we actually got a lot of emails from people that are like, Bro looks like it's the crappiest intrusion detection system in the world. Well, it's because it's not an intrusion detection system. It's not actually doing those things. It's doing something fundamentally different in our organizations. Okay, but why should we be using Bro? Well, okay, let's start breaking down some problems. Over the next few webcasts, Paul is kind of pushing me into some kind of uncomfortable things. I've had opinions, and I've stated the opinions, and they've been very kind of controversial in some situations about how I hate a lot of threat intelligence feeds that are out there today. And it's odd because we actually have another vendor who heard what I was saying and was like, wow, that sounds exactly like what we say. And we're a threat intelligence vendor, and we want to do a webcast. So we're going to be doing a webcast on threat intelligence feeds, and it's kind of odd because we have a lot of things in common with this vendor. So that'll be coming up, I think, the 15th of November. But
yeah,
the other thing that I've been saying,
November 15th with Threat Connect.
Threat Connect, which is weird because they contacted Paul, and Paul honestly thought that they were like punking us initially, and they're now a vendor, and they're like, no, we agree with a lot with what John's saying, and we want to talk about threat intelligence and how to do it properly. So that's really cool, right? But the other thing that I've been ripping on a lot is SIMs, and I think that SIMs are beyond redemption. And I know that there's going to be like one person out of 100 that's like, wow, no, that's a load of crap. Our SIM is fantastic. Well, there you go. There you have your answer. In most organizations, I would say 1 out of 100 organizations, they have a solid SIM infrastructure where they have it set up and they have it configured properly, and they're generating great alerts. There's one actually here in South Dakota that is an ArcSight Ninja. The guy's fantastic. He can do all these different queries and all these different reports and get all kinds of intelligence. And at the end of the day, he has all these reports generated. They go to folders in his inbox, and he doesn't really look at them because they don't have a big enough team to actually analyze the alerts as much as they should. And he's a ninja, and he's very, very good, but yet he's completely overworked, and that happens a lot with us. So what is it about SIMs intrinsically that makes them kind of a train wreck for trying to go through and do analysis for security level things that are happening on your network? Well, a couple of quick things. First, there is no event ID like event ID 666 that says that you've been hacked. And you can basically alert on that, and now you know for certain that you have been compromised. That's probably the biggest single one. Everyone assumes that we can generate a bunch of event logs, ingest the event logs, analyze the event logs, and find evil in an organization very easily. Thing two is white noise. You get to the point where you have so much data coming into a SIM that it's almost impossible to actually parse all of that event log data properly to actually figure out what's going on. And a lot of that has to do with ignorance. And I don't mean this in a horrible way like, oh, you're ignorant, you're stupid, but rather we don't know, so we try to log everything. And the vendors aren't helping with this. The vendors basically stand up and they say, well, you should just log everything. Log everything to ArcSight, log everything to Splunk, log everything to QRadar, log everything to our SIM, and our SIM will handle it. But in reality, in most SIMs, less than 10% of the event IDs that come in actually have rules or alerts written for them. So that means that 90% of what you're ingesting isn't actually being looked at and isn't actually being analyzed. But if you talk to SIM SIM Nazis, they say, well, you should keep that stuff because if you get into an incident, you're going to need it to figure out what's going on. To be honest, I really don't want to sift through a whole bunch of event logs looking at CFMORs and spin locks and thread locks or anything. It's like I just don't care, right? It's not really pertinent to doing solid incident response. So That becomes a problem of white noise and too much data. And then also, if we're trying to look at network level analysis, SIMs are in a really tough spot. They're in a tough spot for a couple of reasons. The first reason why they're in a tough spot is the sheer volume. If you're actually logging from your firewall going to your SIM and you want to do solid connection logging and alerting, and you want to see for connection logs that, let's say, beacon analysis, it is almost impossible for these engines to do this properly because of the sheer amount of data that you have to look at, number one, and number two, the amount of memory, and number three, the amount of processing power that needs to be dedicated to doing that type of beaconing and alerting analysis whenever you do it right. So if you generate a whole bunch of logs that get dropped into the SIM, and the SIM tries to do event logging, not event logging, it tries to do alerting on connections and beaconing analysis, they tend to fail, and they tend to fail because they write very, very basic beaconing modules. For example, NetWitness, the RSA product, they have one that's set up right now where they'll basically do beaconing analysis, and basically all they do is they look at the total aggregate number of connections over the course of a day, and if there's a lot, it's a beacon. And that's a really poor way of doing beaconing analysis, but it's something you can do with the SIM. You can do a total count between two different IP addresses and basically look at that count and look at the ones that have the most unique connections leaving. And that's great for a beacon that's going really fast, but what about a beacon that's going really slow? It gets hard to actually do that type of analysis. The other problem is when you're doing network analysis in something like Splunk or you're doing it in an ArcSight is the issue of connection time. We've kind of touched on this briefly on Enterprise Security Weekly and talked about it a little bit, but spend a little bit more time kind of breaking that down. If you have a SIM and it is ingesting event logs from your firewall, from your WebSense proxy, from your router, whatever is generating connection logs or NetFlow, JFlow, whatever the hell it is that's coming in, and it's feeding that data in, you've got a huge problem if you're a SIM vendor and you're trying to do beaconing analysis and analyzing connection times. And the big problem is time. Whenever we're looking at timing, what does it mean whenever you have a connection? When does that connection begin? When does that connection end? When do you actually log that connection time? And some vendors will log the connection time at the end of the connection. Some vendors will log it at the beginning of the connection. And other vendors, they log it once the SIM, what they do is they have an agent that you can install on their product, and that agent will receive that connection data and forward it onto the SIM to a collector, and then that SIM will replace the date timestamps for whenever it received the event log, and then it logs it with that date timestamp. Or you have some SIMs, they'll have 4 different date timestamps. The connection began, connection end, connection offset. You'll have a connection for the agent, and then a connection whenever the SIM received it. And they really don't clarify which of those fields do what very cleanly, so that becomes a problem. And then you also have vendors like WebSense, where WebSense allows you as a user to basically configure the concept of time and connection on your own. So you can basically say, I want to log at the end, or I want to log at the beginning, and you can do an offset from beginning or offset from the end. And it's completely configurable by the user. Or you have vendors that, so for some versions, it'll log from the end, and other ones it'll log from the beginning, and then other vendors will switch how they're logging timing in between course of 24 hours because different logic actually gets triggered. So the point is this becomes an absolute nightmare when you're trying to do analysis. So if you ever have a SIM vendor that's like, yeah, we do beaconing analysis, we can do this for all these different products, we can ingest all the logs and tell you if there's any beacon there. They're kind of lying. I'm thinking it's more ignorant than lies, though. But if they've never really been down in the weeds, they may get the module working for a specific vendor, and then they just simply throw all the rest of their logs and they do the analysis, and it starts to break. And the reason why it starts to break is because what worked for vendor X does not necessarily work with vendor Y. And that's one of the big reasons why we're huge fans of Bro. Whenever Bro logs, it does it consistently. The timestamps are very, very consistent, and it also is wicked, wicked, wicked fast. So we'll talk more about that here in just a little bit, but that consistency is massive whenever you're trying to do higher level network threat hunting in your organization. You need to have those timestamps to be able to look for those backdoors effectively. So Bro implementations, yeah, we've had a number of customers that we've worked with and that are coming to us, and they have 100+ gigabit connections. It's just massive, massive data connections, and they set up Bro clusters, and Bro can handle it in those organizations. Bro's been around for a long time, like I said, and basically if you have a network card that can handle it, and that's no cheap proposition. When you're looking at 100 gigabit connections, that's an expensive network card to be able to handle it. But if you have a network card that can handle it, and it's configured and tuned properly, Bro can handle that data, and it can generate the logs. That is very, very, very fast. If you look at a lot of products that are out there today, unfortunately, if you're looking at firewalls, next generation firewalls, a lot of these different products, they tend to tip over fairly quickly whenever they get a tremendous amount of data bandwidth going through them. And unfortunately, they don't fall over cleanly. Many times they'll just start dropping packets. They'll lose like 20% of the packets or 30% of the packets. And you really can't query the application to figure out if it's dropping packets. Maybe you see the CPU spike at 100%. Maybe you won't. A lot of these products, the CPU will sit at like 20, 30%, but the way the network buffer is configured is it's dropping a whole bunch of packets before the CPU can actually do analysis on them. And that's kind of weird, but that's something we've encountered in some organizations. So yeah, you run into the problem where there's a lot of vendors that will actually start dropping packets and not really letting you know. So that's neat. But then the other thing is, if you're working with like Gigamon, or you're working with any really good network appliance, you can actually sidechain and do PCAP. You basically do full PCAP off the device, and that's cool too, because then you don't necessarily have to have a bro box immediately sitting in your organization right in line or off a spanning port. You can basically just grab PCAP off the device and then drop it through Bro, and then Bro can actually read it in. So that makes offline analysis very, 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 very effective, and that's something that we do a lot whenever we do our hunt teams on a regular basis here at BHIS and Offensive Countermeasures. So 21 minutes and no Bro. We're getting there. All right, so let's talk about Bro placement. So where you need to put Bro is very, very important whenever you're doing threat hunting. It needs to be on the inside of your firewall where you can see the RFC 1918 IP addresses and the non-routable IP addresses on the inside of your network. You want to be able to see that traffic coming in, hitting your firewall. So you might sidechain it off your firewall. You might have a router before the firewall, but wherever you're at, wherever's doing network address translation, you want to be in the inside of that device so you can actually see the traffic that's going outbound to the internet. You can log it properly. If you don't do it this way, like if you actually set Bro up on the outside of a firewall, on the outside of a NAT device, which we've had customers do, then it looks like everything is coming from the same IP address, which is the NAT device. And that really messes things up. In fact, in many ways, it'll actually make it impossible to do good threat analysis on data connections that are leaving your environment. So if you want to set it up, kind of moving a little bit fast because there's people that want to see us actually using it, Security Onion is where you need to go. Doug Burks has done a tremendous job with this product over the years. He now has Security Onion Solutions where he helps organizations set up Security Onion, and it's not just Bro, but there's a lot to it. So check it out. I know this morning I want to see how long it would take to set up a Bro instance using Security Onion. I think it was done in 5 minutes, and it was up and running. So you just basically install Security Onion, download a PCAP file, and then start doing analysis on that PCAP file. Finally, I wanted to give you guys a slide for practice. I'm going to go through some PCAP files that are publicly online. Yeah.
Hey, John, we just have a question from the chat. So when you play, in respects to placement of Bro in the network, that should be before an internal web proxy?
Yes, ideally. So what we want to do is be able to capture that traffic before it actually hits the web proxy. Because if you put it at the end of the web proxy, all the traffic's going to look like it's coming from the web proxy, and that's going to create problems. We want to actually see those source IP addresses on the inside of the network that are making those outbound requests.
Awesome, thanks.
You bet. So here's some places where you can get some packets and PCAP analysis. The HoneyNet has different challenges. Bro has workshops where you can go through these different things. And we're going to kind of walk through a lot of the stuff that these different online links have, and then kind of go a little bit further, especially whenever we start talking about RETA and doing analysis of Bro logs as well. So let's go through and let's start talking about connection logs. So here we got a screenshot of it. Let's actually go to it. Let me see which one this is. That's the HTTP log. That looks like the, oops. That looks like the DNS log. Here we go, con log. All right. So this is a connection log. So whenever Bro runs, it actually pulls down a whole bunch of data about the connection, and you have all these different fields that are available. You have UID, timestamp, you have the originating host. Anytime you see _H, that's host, _P is port. But you can actually look at the connections associated with each data connection that goes out. So if somebody goes to yahoo.com, you're going to see a whole bunch of connections. Because remember, when you're working with HTTP, HTTP isn't just going to be one session for yahoo.com. Instead, what you're going to see is lots of different sections for each of the elements. You're going to see pictures being downloaded, videos being downloaded, banners being downloaded, and you're going to see all of those as separate discrete connections being made to a variety of different places. Of course, going to yahoo.com, but also 302 redirects to other websites like for advertisements or Akamai for active content and those things. So you're going to see each of those being kind of pulled down as their own connection. So you'll be able to see things like the data size, you'll be able to see the timestamp associated with it, the ports as we mentioned, and then you also see different things about the connections. Was it a SYN connection? Was it just opening a connection? Was it not closed? Was it just kind of a half-open connection? Maybe Bro started doing analysis in the middle of the connection and it never saw the initialization. You can actually look at that and you can actually pull out flags. Or if you're trying to pull down certain data, you can actually see if it was actually rejected as well. So you have these fields associated with each of these different logs. I'm going to go through, I'm going to talk about Bro cut here in just a couple of seconds to kind of break that down, but this is our connection log, and you can see that this is predominantly in this packet capture. It is web traffic and 53 DNS traffic as well. And Bro is smart enough to actually come right out and say, hey, this is DNS traffic, which is being used. By the way, if you guys want to play with this packet capture that I'm going through, I found this handy little website that goes through and talks about doing really basic malware analysis, open security research. A fantastic little blog from a couple of years ago talking about Bro. Some of their syntax is a little bit off. They're actually using commas, and you don't need to use those necessarily for Bro cut and so on. And there's a whole bunch of different scripts available for Bro as well. And we're going to set this up and talk about Rita a little bit later. But that would be your connection logs. Now, what would be some things that you would be interested in? Well, let's say that you had an IDS alert for an IP address. Let's just say an internal IP address 172.16.88.10 generated an alert. For whatever reason, it generated an alert. With Bro, you can actually go through and you can actually set up your command here, and you can actually use things like grep, where you could actually grep out that IP address and then find all the connections associated with that IP address. Or you could use Bro cut, and you could find all the connections between that IP address on the inside and then an external IP address that helped generate that alert. So there's a lot of flexibility that you can have to start asking questions, and really that's probably the best way to think of it. I talked with some people that are really big fans of Bro. We got a couple of people here at BHIS that are just super into Bro. Like we have Lawrence, of course, and Joff is really into it. Derek is probably the biggest Bro ninja for BHIS, and he's going to come on and help me with some of the webcasts a little bit later whenever we start talking about scripting Bro. But he says you got to think of Bro as kind of like a Google search engine for your network connections, using Bro cut, and of course he says sometimes it's like using Google, but you have set and awk. Think about how awesome that is. And I'm like, curling up in a ball in the corner and crying. Yeah.
Hey, John. Just a question from the audience. We've talked about how Bro plays in a physical network. How does it work with VMware NSX?
As long as you can get PCAPs or as long as you can get a span port, Bro's going to be happy. So yes, if you can get a span port, you can do it. Even we were talking about it a little while ago, Paul. Amazon EC2 actually has the ability for you to actually sidechain off port mirroring for the data within your Amazon environment. So any time that you can get span traffic, as long as it plays in the world of TCP IP and you can get PCAP or you can go span, you got it. So Bro works in those environments very well. I will caution you.
I'm unclear the technical details of how to do it in NSX, but I know that I have spoken to people who do claim it's possible to be able to do the same thing as a physical port mirror, but do it within the NSX environment. Similar to ESX.
And I will.
AWS as you were talking.
Mm-hmm. Absolutely, but I will warn you. I wish I was in the room with Jordan and them. I will give you a heads up though. If you're doing it in a VMware environment and you actually start doing that type of span over to a Bro system that's a virtual machine, you have to be very careful. Basically, don't buy cheap hard drives. We've gone through about 3 or 4 hard drives whenever we have Bro set up and we're doing ingest and analysis. We burn through hard drives fairly quickly. It's basically reading the data, dropping the data back on to the Bro virtual machine. And you see a lot of the same problems in other products that aren't open source like Bro. For example, there's some products that have everything up in the cloud and they ingest a tremendous amount of PCAP data and they run into sharding issues with the back-end database. So you do run into problems. So you want to make sure that you have some good solid hard drives. Anything that you buy, I would actually go through and Google ESX. I do packet capture and search specifically for hard drive failures because you're going to see some hard drives that just don't handle it very well. We do see some people that like to do this specifically with SSD drives. defense contractor that George Bakos works with. They do full packet capture and they do Bro for the log analysis, and I think they keep it for a month. Or at least they did keep up to a month of data, and they have basically petabytes of storage that are all running SSD. Now they also have budgets that they can support X number of millions of dollars making this happen, but they basically are doing that by moving over to SSD just so they can handle that level of bandwidth that they're doing analysis on. So be careful whenever you start dropping it into virtualization with a whole bunch of other platforms. I might actually recommend that you would span it off, and then you would basically have its own ESX box where it's just handling its own traffic at that point. If you're running multiple virtual machines and this on the same platform, you might run into a handful of problems, but once again, that depends on your hard drive. That was a long answer, but I know that because I've had to write the check for the hard drives when they fail, and that's a painful, painful, painful thing. So, Paul, any other questions or follow-up questions on that?
No, the people chimed in and said yes, they've done it with NSX before, and someone was kind enough to post a link as well.
Ooh.
Someone's asking how much space should you plan to have Bro to have enough space for the traffic that you're collecting?
Okay, so when you're looking at Bro, remember you're not doing full packet capture. And that also depends on what you're actually logging with Bro. If you actually have Bro set up and you're actually going to log files, all the files that are actually going through and you're doing full packet capture, it's going to be a lot of data, right? But Bro, generally, if we're looking at actually cutting down PCAP data into just Bro logs, we've seen where we've had terabytes of PCAPs that actually drop down to a few hundred meg of Bro logs. Because remember, what Bro is capturing is kind of metadata. It's not actually capturing full packet headers at this particular point, but it's breaking down information about connections, it's breaking down information about DNS, it's breaking down information about HTTP. So the real answer is it depends on what you're actually trying to carve out, but at the same time, we've seen it actually come down to not very much data at all. In the grand scheme of things. In fact, whenever we do hunt teams with organizations, they can ship us out a hard drive with Bro logs, and many times it's USB stick, as compared to doing full packet captures where they got to send like a massive hard drive or two out to us. But that's a big concern. That's also one of the reasons why we built Rita on top of Bro, is it makes it very flexible. We can actually put a Rita agent on a system that's running Bro, pull these logs off, and then do the analytics, and we don't have to worry about throttling the entire network. Be wary of any product that does full packet capture, especially full packet capture up to the cloud. Even if their technology is solid, they may run into issues once they actually get it up to Amazon and start doing the analysis. We can do that right, but once again, it's a very hard thing to do. Good question. Next question, Paul?
I was just going to respond to Sean, who asks, what do you have recommend for a TAP solution on the physical side? My response was Dualcom makes very, very small. They even support gigabit, but Dualcom's a great name, known for tapping. And on all the way up to the enterprise side, I'm sure there's a lot of stuff in between. We see a lot of Gigamon on the enterprise side.
Yep, and that was one of those things when we were kind of setting this up. Paul's like, we've got to interface with Gigamon, and we basically spent 5 seconds looking at their website and saw that we could get raw PCAP spanned off of it, and we're like, well, we're done. And it just worked.
Yeah, and it's a pretty common deployment that we've seen in the enterprise. Another person was asking about, is Bro in use in the enterprise, essentially, something about the open source solutions. John and I have personally seen it in a lot of large. We were actually kind of shocked how many large enterprises already had Bro deployed.
Yeah, and that was another one of our big things. We were initially trying to do analysis on our own by loading the data, and that was becoming problematic. And then we also tried the SIM thing for a few months. This is like a year and a half, 2 years ago when we got started. And once we started talking to customers, we're like, well, we got Bro, and it was done. It was one of the easiest transitions in the world. And Paul, I can't remember how many installations. Isn't it like 47,000 different organizations are running Bro right now?
Yeah, I think
you had that number at one point.
Yeah, a year or two ago, I want to say they claimed their user base was around 40,000. That could have also been a download number as well, but I have that statistic is buried somewhere. But I'd be curious to see from the Bro project. I got to reach out to them and get some current numbers, because I'm sure it's grown from even the numbers they posted a year or two ago.
Well, and the other thing about that is one other kind of to cap this out. If we're working with an organization for a pen test, or we're working with an organization for a hunt team, or we're working with an organization to implement AI hunt, it's pretty much the organizations that are running Bro and have someone that knows how to use Bro. They're without question kind of the top of that kind of the top of that tier of organizations that are doing security right. Bro is not something you just blindly implement in your organization. You're like, oh, I don't know what that box is doing. It blinks. But no, usually Bro is installed by people who want to dig in and they actually want to know what's going on in their network.
Sure. I'll let you continue, John. I'm collecting the rest of the questions, and I'll ask them when there's a good opportunity. So please continue.
Sounds good. The next one, this is DNS. This is, all right, so this is HTTP logs. So somebody was asking whenever you run Bro, do you want to put it before or after your web proxy? And you definitely want to have it before. Once again, once the data hits your proxy, once your data hits your network address translation device, all the traffic that Bro sees is going to be traffic that is after that device. So it's all going to look like it's coming from that device, and you're not going to get very good intelligence out of it. So with this, the reason why this is important is you can actually grab things like user agent strings. You can grab things like what hosts are communicating out. You can actually see what are the requests that are being made as well. So that's kind of getting into Bro Cut, but let's go ahead and play with this just for a little bit. Let me sit down here, all right? So if we actually look at this entire log, let me see if I can actually make my terminal logs a little bit better. Make this 15. Let's kick this up to 17. There we go. Close. All right. So if we actually just cat out the HTTP log, and we're actually just looking at the raw traffic that's leaving, you can see that we have the URLs that are being requested. The hosts, of course, are right here. The internal host is right here, making the connection outbound to port 80. And then here is the URI that's being requested. And you can see that this URI is nuts. You can see this long, randomly generated URI. Now, that's kind of one of the hallmarks of malware. One of the things that we do whenever we're looking for data and doing a hunt team is looking at those long URLs. Long URLs can be used for a variety of different things. It could be used to try to bypass things like WebSense that are doing blacklist checks for known sites that are hosting up malware or pages that are hosting up malware. You can also see malware that's using base64 encoded URIs or parameters within the URI to communicate outbound as well. So there's a number of reasons why you would see the URI get ridiculously long. Now this is kind of cluttered. You can see up here, these are the fields that we actually have, right, that we can actually pull down. And with Bro Cut, it's a really nice little utility. You can actually choose which one of those values you actually want to pull down. So I'm catting out HTTP log and piping it through Bro Cut, and I got ID, org, host, that's the originating host, and then of course the host that it's connecting to on the outside. So you can see these really long user agent strings being used. So that's kind of cool. Now I may want to pull down the user agent string associated with it, and you can do that as well. And plus you can change the order of these things as well. So you can say you want the user agent to actually be first. You can absolutely do that just by shifting out the order of these different things. Paste it in. It kicks it out, so the user agent string is now at the beginning. And that's really powerful because you can actually start sorting these things and then, of course, actually piping it through and grepping out different IP addresses using sed and awk and things of that nature to make it really easy to start asking these questions from the systems on the inside of your network. So that's kind of neat, right? And the final one I wanted to show you, now there's more, and I'll show you those here in just a couple of seconds, is here we got DNS logs, right? So you can actually see that what I was pulling down is ID, original P, and then I've also got the query that's being made to these different systems, and you can see we have these random named .com and .biz and .ru sites as well. So this allows you to actually go through and see if there's any hosts that your systems are talking to on the outside of your network. Now, one of the tools that we wrote, it was written by Ethan Robish, that helps quite a bit, is you can run a tool called DNS Blacklists. Now, DNS Blacklists allows you to look at all of the different IP addresses and look at the queried hosts that are going outbound and compare that with known blacklists and then see if there's any of your systems that are communicating outbound to bad IP addresses or bad hosts. Now, quick heads up. You're going to see your systems making queries to bad hosts and bad IP addresses. Just through the standard day of somebody surfing the internet, advertisements loading, you're going to see systems with 1 or 2 or 3 hits where systems are going through and they're hitting 3 bad IP addresses or bad hosts or bad domains a day. That's pretty normal. Once you start seeing a system that gets to like 6, 7, 10, 20, or 100, all of a sudden now it becomes a lot more interesting. It becomes a lot more interesting. Because that's either a user that is engaged in very risky surfing behavior or that is a user whose system is actually compromised, communicating outbound to bad bad systems. Now let's talk a little bit about the utility of this. So some of the people that we talk to say, well, there's little value in actually doing a blacklist check for DNS data because the bad guys are shifting their domains very, very quickly. They're shifting their IP addresses very, very quickly. So there's very little value in actually trying to track that down. Yes and no. I would agree if I'm trying to do a DNS blacklist today, right now, at this point, yeah, the blacklist that I'm pulling offline from IP void or URL void or whatever threat intelligence feed you're using is going to be old. And that kind of gets into one of my gripes against a lot of threat intelligence feeds is by the time you start trying to if you're trying to use a threat intelligence feed by simply updating blacklists in your organization, you're not using it correctly. But because the bad guy is going to be shifting their domain, they're going to be shifting their IP addresses very fast. However, what we have found whenever we do hunt teams with organizations, we'll get their PCAPs or we'll get their bro logs, and then we won't be able to get around to the actual hunt team on that PCAP data for like 2 weeks or a month after it was collected. Now that's stale data. What's the value in looking at stale data? Turns out there's a lot. Well, current blacklist with current traffic, I'm going to be missing a lot of bad domains and bad IP addresses. However, if I go forward 5 days, the IP addresses that are evil now, the URLs that are evil now, the host names that are evil now are going to end up on those blacklists. So what we recommend is you can actually run with current up-to-date threat intelligence feeds or known blacklist feeds, but look at data that's like 2 weeks or a month old, and then all of a sudden these systems that were talking to a bad IP address a week ago, 2 weeks ago, are now showing up on current threat feeds or current blacklist feeds. So there's a lot of value in actually doing that on kind of some older data. I mean, if you have the PCAPs or you have the bro logs, bro will log, and then the next day it'll set up different logs, and you'll basically have different logs for each day. You can actually do this type of analysis on some older data in your organization and actually find some fairly interesting things about systems being compromised with some advanced attackers. All right, now the power for actually going through the... Oh, yeah, go ahead.
Yeah, so hey, this is Mark. I think that was a great point you made about looking a little bit back in time. And there's another thing. You can look at some of these URLs and actually see patterns that are indicative of something being, say, created by a domain generation algorithm, which a lot of crimeware actually does to go reach out. So there are tools. We put one on our Endgame GitHub that you can use. You could bang that bro output against the classifier, and it actually uses some machine learning in order to say, hey, these URLs are very likely to have been created by a domain generation algorithm. So that's a pretty neat thing to do. And the one other thing I'd like to point out about the data you were just looking at is the user agent strings. You can actually look at that because a lot of malware has hard-coded user agent strings as it's doing a command and control. And if it's showing if you're all running Windows and there's a Mac or even an Android user agent string in your data, you might know you have something weird going on. So that's another good way to find, if you have a fairly homogeneous environment, find things that stick out like a sore thumb just by staring at those user agent strings. And show some
all of a sudden you got a Windows XP system and a sea of Windows 10. That might be kind of weird.
Yeah, it happens.
So yeah, I mean that's something that we do a lot when we're taking a look at it. And Paul, what was the name of the DNS tool that Joff released that also looks at DNS domain name generation? Can't remember. Paul, he's going to...
It's TachyonNet.
Yes, TachyonNet. So there's a number of tools that can actually look at that. Endgame has one. Mark, could you do us a favor? Could you send us that link so we can share it out with everybody so that people can pull it off your GitHub page?
Yeah, absolutely.
And then if Paul could pull down TachyonNet. We had Joff on, I think, about a month ago talking about TachyonNet. And it was interesting how he was looking at domains being generated, and just by things being spelt just a little bit wrong, it could actually trip some alerts on these different domains. And then the other thing that I know Joff's been working on is how old is a domain. If a domain has been around for 15, 20 years, that's somewhat interesting. But if a domain, one of your systems is talking to a domain that just started up a week or 2 weeks ago, all of a sudden that becomes even more interesting. And you can even do some analysis with SSL certificates as well. Doing that, but we'll talk about that more in another webcast. So very good points, Mark. Thank you. So where is all of this actually going? Where are we going with this? Well, eventually what this builds up to is we build upon the foundation of using Bro, and then we get into RITA. RITA, Real Intelligence Threat Analytics, of course named after my late mother. And the whole point of this tool is to ingest bro logs and do some hard analysis, right? To kind of break things down. So kind of setting this up very quickly, we'll actually give you guys the math and the code in a subsequent webcast because that's just fun. But you hear a lot of people talking about next generation AI, talk about machine learning, and there's a number of different algorithms that you can actually use. And one of the sets of algorithms that we use is k-means k-clustering for basically trying to identify quote unquote evil traffic on a network. So kind of give you an idea of where we're going on this foundation of Bro. All right. So we talked about connection logs, right? So let's just talk a little bit about how we could use some of these functions for just reading connection logs, just one simple thing. So whenever you're trying to identify a beacon in an organization, there's a number of ways that you can try to identify beaconing behavior. You can try to look at it in these three main ways, and there's other ways that you can look at it as well. And let's imagine that kind of the intersection of each of these lines is a perfect beacon, right? Let's go through each of them. So if you look at an interval, how long does it take for a system to actually make a connection in between each heartbeat for the malware beacon? Let's say it's a perfect 2 seconds, perfect 5 seconds, perfect 15 seconds, perfect minute, perfect 17.5 seconds. But every time it communicates on a regular interval. If it's communicating at a very regular interval, that would be a perfect interval heartbeat. Now, to be honest, there's a lot of legitimate software that does this, so you have to have the ability to actually filter out or whitelist some things like Dropbox or Gmail or things like that, which creates a whole separate slew of issues. But at any rate, for right now, that's a perfect interval heartbeat. Now, there are malware specimens out there that have the ability of actually programming in jitter, so it can actually randomize when it's actually making those intervals, but it's still going to cluster by and large for most malware. However, there is some malware that truly randomizes their interval. Over a long enough scale, it actually creates a flat histogram, and you can actually identify it. But in shorter scales of 24, 36, 72 hours or a week, it's really hard to actually see that interval patterns start to emerge. So that's why you can't just look at just interval. You got to look at a number of other things. The other thing that you can look at is the data size. How much data was actually transmitted for each of the connections? Whereas malware beacons, whenever they're making a heartbeat out, not every single packet, but most of the packets will be the same data size. Let's say that every single time it makes a connection outbound, it's doing a 2K request, right? It's just 2K every single time. They may be randomizing the interval, but they may not randomize their data size of which being transmitted in each of the heartbeats. Connection time is another way that you can look at it. Connection time is once a connection is made, how long is that connection established? It's different than interval. Interval is in between the connections. The connection time is how long does that connection stay up. So let's say for a heartbeat, the connection time is 2 seconds or half a second. Or not, it's just basically a very, very quick connection, but it's consistent in establishing the connection and then tearing down the connection. It's doing the exact same interval every single time. So what you develop is you kind of develop a three-dimensional plot of trying to identify beaconing analysis on a network packet capture by using Bro, because Bro gives us those connection logs. We can read in the connection logs, and we can use Rita to actually go through and do analysis on those connections that we receive from Bro to actually kick back and say, these are the systems that are exhibiting beaconing behavior. Now, once again, some of these systems are going to be legitimate systems without question, but we can also filter out or whitelist those. So if you have something like Dropbox or you have something like an SNMP trap out online, which we have seen, you can actually filter those, and you can actually start getting down to the point where you're actually getting some very, very interesting beaconing analysis. And if you guys want, there's a couple of things you guys should look at. Just giving you guys a couple of quick websites. First, I wanted to give props to John. John said Bro is his cornerstone. He's a huge fan. Already maybe mentioned it, but I definitely give a shout out to the Freenode Bro channel, BroCon and Bro for Pros, and Try Bros to get started. Those are all absolutely great websites and different cons to actually go through and check out. Also, Bro has a fantastic online kind of man page talking about what each of the different fields actually means, so you can actually set up your own queries for these different things. So be sure to check those out. And there's tons of little challenges out there and absolutely everything. But I wanted to give you guys kind of a heads up on where we're going. So we are headed towards eventually the Rita project. That's where we're headed. We're going to spend some more time talking about Bro and kind of setting up Bro a little bit further in organizations. But Rita is our project that actually reads the data associated with Bro, and it's a GitHub project. Come on, there we go. And you guys can download it and install it. We've given you step-by-step instructions to do so, and at its heart is Bro, and these are the instructions to actually establish it. It's written in Golang. Golang is awesome because it's a very fast, multi-threaded, cluster-capable kind of front-end, or not front-end, coding language, and it's built on top of MongoDB as well. So this is something you guys can play with, and this is ultimately where we are going with all of this stuff as well. So I want to hand it over really quick to Mark so we can talk about their stuff as well. So let me do this. I go attendees. I go to
John,
staff.
while you do that, I know a lot of people have questions. There was a question that came up more than once, so I thought we'd take the time to address that. If we don't get to your question, John, I will make sure to get your questions answered and send that out to the list. I was actually thinking we'd do an Enterprise Security Weekly episode on it this week because there's a lot of great questions about how to use Bro in the enterprise. Thank you for all of your questions. We're going to do a whole segment, make sure they all get addressed. More than one person did ask, how does Bro handle encrypted traffic such as HTTPS?
Well, once again, one of the cool things about where we're heading with Rita ultimately is it doesn't really matter. What we're looking at is we're looking at connection intervals. We're not actually looking at the payload within that traffic. What we're trying to do is look at the connections that are being made. So all the things that are pertinent for us to actually do analysis are still there. We're going to be able to see the connection time. We're going to be able to see the URI that it's going to. We're going to be able to see the source and destination IP addresses. We'll see the resolution in the DNS logs. So everything that we need to look at is present. It's actually present there for us. Now, usually whenever you're doing hunt teaming, one of the things that's important, and I think Mark would agree with this, is hunt teaming gives you indications, and you have to go and you have to do analysis, and you have to start looking. So yeah, you're not going to be able to actually take those packets apart and be able to decrypt all the data. Now, you may have SSL decrypt capability in your environment already. You may be doing full packet inspection for web traffic that's going outbound, and you imported a certificate on all of your systems. Now, if you have that, you'll be able to see that SSL data. You're going to be able to see it unencrypted. But remember, where we're going is trying to get away from signature-based detection, but actually trying to get to the point where we can look at the behavioral analysis of the traffic, and that's completely independent of what is in the payload itself. This is also interesting whenever you're talking about Europe and the European privacy directives. It gets you around that, so you can actually do security without actually impinging on the privacy of the users in your organization. So that's important in the EU. It's also important for like universities as well. So I wanted to hand it over to Mark real quick. We'll come back and we'll do some more questions here in a little bit. So Mark, are you still with us? Uh-oh.
That's how you work a microphone. I'm good now. All right. All right.
Yep.
Great. So we talked a lot about hunting on the network. There's a lot you can also do on the host, and in fact, I would say that the host almost gets noisy in a different way, in that there's so many different things you can look at on a host to find evidence of bad. There's logs, there's files, there's registry. You can actually collect network data on your endpoint. There's persistent files. There's running processes. There's so many things you can look at, and it comes down to a matter of what do I want to focus on to find bad in my hunt, because that's what this is all about. Hunting is, the art of finding evil in your network without having a specific signature for that evil. So you really have to understand, what does evil look like? And what we really like is the MITRE attack framework and some concepts that we're seeing in the industry now called purple teaming, which is really like focused red teaming with the blue team side. So it's the red team saying, hey, we're going to do a pass the hash attack on the network. Let's tell the blue team we're doing that. Let's focus on a few systems, and let's help the blue team understand what that pass the hash looks like on the wire. And kind of going through the attack matrix, which tells you a lot about what are different techniques attackers can use at each phase of their attacks, everything from dropping persistence all the way through command and control and exfil, and try to have modules in your defenses of how to find that specific bad. And if you layer enough of these things together, it becomes very difficult for an adversary to operate on your endpoints without you seeing it. So in terms of data collection, I do want to talk to you all about some methods and also some kind of free ways to start at this. We don't want to just talk about buying a big platform right off the gate. You probably want to get a taste of this. So PowerShell, Windows Remote Management, WMI, these things are all your friends for data collection. Makes it pretty straightforward to collect data off of remote endpoints. ETW, Event Tracing for Windows, is great too to get things in real time. It's pretty tough to deal with and kind of horrendously documented, but Microsoft just released a framework that I encourage folks to check out called Crabs that makes things a little bit easier to deal with ETW. So once you've focused on your data, and collected it. You have to store it. A lot of, if you're going to do this for free in Elk Stack, Elasticsearch Kibana backend is probably the way to go. Process it. You got to say, hey, what do I want to look for? Looking for outliers is a great thing to do. What just doesn't look like everything else in the environment? And there are some specific things you can look at in different types of artifacts that should jump out as suspicious right away. And then, of course, you pursue things, determine if that thing is a real detection or is it noise, and then go on from there. So let's see. So I'm going to jump through these things pretty quickly here, but the first thing I like to do is hunt in my persistence locations across my endpoints. If you're doing this for free, Windows System Terminal or Microsoft System Terminals has a tool called Auto Runs, which a lot of you have probably used. You can upload it to your endpoints, run invoke command to run this thing remotely, and enumerate persistence locations across all of your endpoints. I mean, you're all probably very familiar with things like run keys in the Windows registry, things that execute on startup or startup of an application. The great thing that Microsoft did for us is they made it really easy to hide different persistence locations. There's over 100 places you can persist code in a modern version of Windows, and out the gate there's something like 950 default persistence items on just a Windows 7 clean VM. It's amazing. And so then as you add software to the environment, that just grows from there. And of course, malware, that gives it a lot of noise to hide in, a lot of things it can try to look like, and a lot of places to go sit that might be hard to find. So you collect all this data across your endpoints. If you've got 10,000 endpoints, you multiply that by 1,000, and you've got a lot of stuff to go dig through. So how should you deal with that from there? So a good first place to start is looking for malware. So one thing you can do is enrich with VirusTotal. It's not a signatureless technique, but it's certainly worth doing, and System Terminals Auto Runs has that integrated in with the platform. So it's a great thing to look at. So if VirusTotal thinks it's bad, it can tell you that it's bad. Even better, you can tie this to a malware detection capability that doesn't rely on signatures. We happen to have one at Endgame based on some data science techniques, and that can tell us, for a never-before-seen piece of malware, whether it's bad. Other stuff you can look at that really gets more into hunting, things like strange execution locations. It's awfully odd if something executes out of temp or the recycle bin. Look for file masquerading. So if somebody wants to look like something that might just pass a visual eye test, why not name your thing LSAS but put it somewhere else? That might blend right in. Or just the basic spoofing attack. Maybe you want to call it LSAS5, and that might blend in, and put it in System 32, and you're off and running. So just some strange stuff there. And basic outliers, look for strange signers. All these things you can stack up and find weirdness. You really should also then, the next good thing to do is look in your running processes across your endpoints. Collection of what's running right now is pretty easy. There's, I throw up on the screen a way to get that via WMI and just get data right now across your endpoints. Or you can look at some forensic artifacts, some things that have executed in the recent past on your endpoints. You can dig into things like the shim cache, the am cache, prefetch. There are good parsers out there to collect all this data and make some sense of it. It'll give you some command lines that have run in the recent past, for example. So again, go look for malware. The thing I like to do is look for parent-child outliers and oddities. So a very obvious thing to think about is, well, how does command.exe normally start? You look for things spawned by Explorer, things of that nature. Is it normal if I see command.exe spawned by my web browser or Adobe Reader? That's probably pretty strange, and you might want to go ahead and look at that, because that might be good evidence that somebody has popped a shell through an exploit on one of your boxes. And there's 1,000 different ways you can take that. You can look for reconnaissance sequences. So an entire thing to look at in attack is, once an attacker lands in a box, they're a little bit blind to where they are and what they can do from that box. They want to know, hey, what other machines are in my environment, and what files are sitting here that I might want to collect or do something to. So there's some pretty typical commands that comprise recon sequences where they say, hey, can I get to the internet? I do want to ping, run some trace routes. What other machines can I see? What's in my domain? Like a whole series of commands you can run with the built-in net.exe command, or just enumerating the file system. Look at do a tree or a full dir walk of the file system or the documents folder to see what's there. You see these things happening. One of these things on its own might be a noisy thing to be alerting on, but if you see a number of these things tied together and a number of these things that might be outliers, you don't see these things having run recently or being run on other boxes, you might want to take a closer look. And outlier modules is a little bit more sophisticated thing, but if you see, say, a DLL being loaded into Outlook on one machine but nowhere else across your entire environment, that might be an indication that that DLL is malicious and it's doing something evil through Outlook. And we've actually seen some examples of attackers doing exactly that. Continuing here, communications hunting. John just did a great job talking about what can be done through Bro. You can also do a lot at the host, and it's actually nice in a way to generate some amount of data on your endpoints to do network hunting, because you can tie it directly to the process that generated that data, especially if you're using ETW to subscribe to those events. So things that might stand out here are outlier listeners in your environment. I only have one machine listening on port 5741. Like, maybe that's odd. Maybe it's malware sitting there waiting for command and control. And another cool thing is looking at things that aren't browsers talking out on web ports that you don't see commonly in the environment. So you could, that kind of is a process ID tie in there that gives you that level of enrichment. You can say, hey, it's some random exe talking out on port 443, and I don't see it anywhere else doing that. That's pretty strange. Maybe I should go look at that. And then we talked a little bit earlier about random DNS requests, and you can also do a similar type of thing to look for spoofing, things like facebook.com with 3 O's in book. We've seen things done like that time and time again. Lateral movement is another great thing to look for across your systems. You can look for generation of remote services, and I put some details on this particular slide. Past the hash attacks, you can see evidence of RDP. All these things are like kind of pretty easy to pinpoint things in your event logs. They're not always indication of evil, and especially if people do these things in your environment legitimately, you're going to get some noise. But as you go, if you collect this data over time and understand your users and your systems, you can start to generate pretty high confidence alerts that something weird is going on with these type of approaches. And last up, I do want to talk about what about in-memory stuff? I think we've seen that in-memory only attacks are becoming more and more common. So can I do that via my hunting approach? And the answer is you should. With recal volatility, other memory forensics frameworks, these things aren't exactly built to be doing things at scale across tens of thousands of endpoints. You can do some search, like you can use Yara to look for signatures in your memory through this, or look for other things like that. I think largely this in-memory only is a detection of in-memory only attacks is pretty difficult for many existing hunt solutions, and it's really difficult if you're just trying to get a taste for this and roll your own capability. I think you'll find that these tools don't really scale very well. So just a quick summary, that was a lot of material, I know, but I want to give people a kind of a touch of a lot of different things you can do on the host. I want to leave people with the idea that you really can find maliciousness on your network without signatures. Like, hunting really does work. You have to be focused on it, you have to be dedicated to it, but it will help you find bad stuff that your signature-based detection stack misses. And you actually can do a lot with free tools. Your data is going to be noisy, and I've talked to a lot of folks who have tried to do hunting with the free tools, and the part that actually they find most painful is not the analysis side of things, but the collection of all this data and data management, running their own elk stack in the back end and managing the servers and all that. They're finding that extremely painful. So you may not want to, you might want to get a taste with these free tools and scale up with a real platform that does a lot of those boring things for you. And the in-memory side of things, free tools just really don't tend to get you where you need to be. We've put a lot of focus at Endgame, my team, at enabling hunting across memory to find in-memory only attacks, and have some pretty cool capabilities lined up in our platform where you can find, say, injected code across lots of endpoints very quickly, kind of doing things that you can't do with free tools. But you really can do a lot with free tools, and I encourage everyone that isn't hunting right now to do so. And if you like that, take a look at Endgame or some other EDR or hunt platform that can help you do these things at a little bit greater scale.
Hey, Mark, I have a question from the audience. They ask, what about endpoints other than Windows-based systems?
Yeah, so you can do a lot of these similar things. They all extend. There's great things out there like OS Query or AuditD. There's different frameworks that collect data off of Mac and off of Linux. I wouldn't claim to me myself be a Linux or Mac hunting expert, but you can look in your logs for strange logins there. You certainly can look at network comms. You can look at running processes and loaded modules. So the collection differs in terms of the exact, because the internals of the OS are all different and what artifacts are left behind are all different. But the concepts extend to those different operating systems, and you're just going to have different detection capabilities and probably a different back-end data architecture for each one of those OSs, but it's all very doable. And that purple teaming approach completely fits in with Mac and Linux. If you want to see understand what the attacks look like, and then go do them and find the logs and find the artifacts and go plan your hunt.
Awesome. Thanks so much, Mark. John, thank you again. I just want to point everyone to the slides, and the audio will be posted. I'm not sure exactly where yet, but we will be making those available. So those will be accessible to everyone who registered for sure. So look for communications on that. As always, you can find John and I on Enterprise Security Weekly. You can subscribe to that show at securityweekly.com/subscribe. You can visit Endgame's website, and I would recommend to our audience to check out their blog. Is it endgame.com/blog? Fantastic technical articles posted on the Endgame blog.
And one more final thing. We will be releasing, be watching the BHIS Twitter feed tomorrow. We will be releasing, I don't know if it's a 0-day, Paul, but we have a two-factor bypass technique for Outlook Web Access. Portals that if you're running Outlook Web Access in your organization and you're using two-factor, you're going to want to watch it. Watch our blog for tomorrow because we're going to be releasing something very cool. And I'll also be releasing it at the Hackfest Summit tomorrow in DC with Ed Scotus.
Thanks, everyone. Our next webcast is November 15th on threat intelligence. Thanks, everyone, for tuning in today. We'll see you next time.